Welcome to part 3 of our discussion with Rex Davidson, OEM president and co-founder. Well, let's segue that right into the next conversation about blades. Because I live in North Carolina, I live in NASCAR country. I use this analogy all the time. Rick Hendrick does not spend $300,000 on a race car and go put Walmart tires on it. So the blades are equally as important as the machine itself. If you have a great machine and poor blades, you're not going to get the performance out of the machine. So talking about the blades, let's start with the composition of the blade. I know there's different metal compositions. A lot of people spend a lot of money with metallurgists trying to figure out what that key Rockwell setting is. I know OEM is kind of known in the industry for making good quality blades, and I know you actually do most of the work there in your facility. You don't just buy and resell. Talk a little bit about the blades and the steel and how you source it and what makes your blade special, just generically.
Okay, being in this industry for as long as we have, we've seen a lot of stuff come, we've seen a lot of stuff go, and one thing that we've discovered is you pay a little bit of extra money to allow the customer to get a little bit more life out of it. That's what everybody's looking for. I'm old enough now where I'm not looking for those deals anymore. I'm looking for things that I can install and make them last longer, make them a better deal in the long run, not just the initial cost. So we choose and have chosen for many years to use a higher carbon content in our blades. Everybody uses a spring steel, and some of them use a lower quality, a lower carbon content than what we use. And some of the processes that are used to sharpen the blades, they'll heat the blade up and actually take the temper out of it. Most of the blade material that we buy is a 51 Rockwell, which is it's really hard, and the carbon content allows that blade to stay sharper longer. But the way that we actually sharpen our blades in-house, we use a flooded way to keep the blades cool, and so we sharpen our own blades, we cut our own blades, we ship them all over the United States, all over the world. But the long and short of it is, if there is a better product out there, we're going to find it. So far, we have found the best for this industry. And if you're driving forwards with 500 to 1,000 pounds of pressure on any type of product, whether it's carbon steel, spring steel, even carbide, it's not going to last very long. But we do have the longest lasting blade out there.
Well, let's talk about the blade itself, some kind of common sense questions. The length of the blade. If I'm a contractor, common sense says use the biggest blade I can get. I'm going to take up the most material on each pass. But I know that's not necessarily the case. Touch on that a little bit about why you have the different lengths.
We sell blades from 4 inches to 24 inches in 2-inch increments. So, we actually even special cut some blades for some customers that are used to some of the old competitors that are selling a 13-inch blade. Yeah, we'll cut your special blades. Instead of buying a 12 or a 14, we'll cut you a 13. But if you're taking up a carpet material and you've got a lightning machine and you want to push a 24-inch blade through some carpet, good luck, cowboy, because that's a lot of pressure to be trying to push with a 2,500-pound machine. If you could keep the tires from spinning, it would probably do it, but you just don't have enough butt in that machine to push it. So yeah, if you can push it, let's do it, because the more square inches you can cover, the better off you're going to be. But as you spread that blade length out over 24 inches, you're spreading your weight over a larger area, so you have less down pressure, and you're going to get less glue, and you're going to be less effective. So if we go on a job and it's first thing I'm gonna do is I'm gonna try a 12-inch blade. That's in the middle of the spectrum. If a 12-inch blade, I can push it through there real fast, real easy. Maybe I'm going to go up to a 14 or a 16. I can push it through there fast and easy. That's great. If I'm doing a VCT job and I can push a 12-inch blade and that thing gets dull after 15 minutes and I got to jump off of it and resharpen it every 10 minutes or something, then hey, maybe I can try a 10-inch blade or an 8-inch blade and not have to have such a sharp blade to do the same job, and I stay in the seat, and as long as that machine is driving and not waiting for me to sharpen it, I'm making more money. So we're gonna test a wider blade first, and if that is effective, we maybe even increase it to do a better production, or we're going to decrease it to give us more of the adhesive removal. And there are a lot of times when we see carpet with VCT under it. Okay, do we make that decision on early on? Do we want to take both products up at the same time? If we do, we're going to go with a shorter blade, a narrower blade, and take them both off at the same time. But if we're going to take them off one at a time, let's go to a bigger blade and let's knock this carpet off here and then come back and get the VCT.
Talk about the thickness of the blade. You see them on the market from 0.62 up to 1/4 inch thick. What's the significance of the thickness of the blade?
Okay, we don't sell here at OEM. We don't sell any of the 0.62. Our machines are heavy enough where you would really have to put a wide 0.62 on there to be able to keep from bending or breaking the blade. And I think that's a main driving decision making in the process is, okay, how heavy is my machine, and are we going to run a 3-inch or a 4-inch blade on a twister? Probably not the standard duty, which is 0.94. If you're in a tough enough environment where maybe you're doing epoxy, maybe you're doing some thin set removal where you're running a 4-inch blade, probably the heavy duty or the extreme duty, which is a 125 or a 187 thick blade. But if you're running, trying to do some VCT with a 3/16, the 187 thick blade, it does not form to the floor like maybe an 0.94 would. So if you're trying to run a 12-inch extreme duty blade taking up VCT, it's not going to stay sharp any longer than a 0.94 would. But it will do a little bit better job because it's going to flex and it's going to maybe get down in underneath those little tiny bird bass that are common on these concretes that we're working on. But whenever you're doing some of the VCT out there has got a lot of patch under it, and if you drive forwards and the blade starts getting dull and you start tilting that blade up, getting a little more of an extreme angle on it, and you hit some of that patch materials, possibly you're going to break that blade. Or maybe some of the floors have maybe some EMT sticking up 1/8 of an inch, or maybe some studs sticking up. So you would go to a heavy duty blade to keep the blades from breaking. Now we all have those customers that have a mindset that the heavy duty blades are all they will ever buy. I sell a ton of 20-inch and 18-inch blades, that all heavy duty blades to certain contractors, that's just what they use. That's what they have found is the best for them. Me personally, 20-inch blade needs to be a standard duty blade so it can, you're not spending as much money on it, and it does flex a bit more.
And you kind of alluded to it earlier, the angle of the blade. How do blades correspond with the angle that they're typically used at? Is it a sharp angle, or is it more parallel with the ground? Talk a little bit about the importance of the angle.
Okay, one of the things that you'll find about our equipment is whenever we're initially engaging the floor with a brand new blade that's razor sharp, you would want that blade as close to being parallel to the floor as possible. So you're slicing off the floor and you're utilizing that extremely sharp edge as best you can. Now, as you drive forwards and it's rubbing on that aggressive surface and you're diminishing the sharpness of the blade, you just hit the lever over there and you tilt that blade up a couple of degrees, and you go make another 3 or 4 swipes and you tilt up a little bit more. But then the farther you tilt that blade up, the more extreme you get that blade angle, the more you are pushing the material off versus slicing it off. And it starts diminishing the effectiveness of the blade. It reduces the effectiveness of the machine itself. So where, let's just take some of the rubber flooring, extremely hard to push off. Put a brand new blade on there, you get your blade low to the floor, and the machine drives it through, and it's very easy to push. Now, you use that same blade longer than you probably should. You have that blade tilted up on almost a near vertical pitch. Now the machine can't even push it because you're trying to bulldoze that material off instead of slice it off.
Good. Rex, I think we've pretty much hit on all the other points in the conversation. Is there something else that you'd like to talk about that I missed?
Okay, we're always improving. We're always improving the equipment. We're constantly getting feedback from customers. I mean, we've been building some of these machines for 23 years. We're a small organization. We've got 7 employees, including myself. So if we get a really good idea, or somebody says, hey, I've been driving this machine for 15 years. Can you do this? Can you help us improve this? So this is an issue that we've had on this machine, or if it was this or whatever to improve the effectiveness of it, we instantly employed those things. And so right now we're working on improving the Lightning machine. The Storm machine, the Storm SS, is a compilation of 2.5 years of improvements. We've never had a machine that we've had so many improvements on so fast. But that machine is not the same machine it was 6 months ago. It's not the same machine it was 2.5 years ago. Man, what a fantastic machine it is now. Dual onboard chargers, changeable blade bars. So many different improvements on that machine. So yeah, we're really excited about what 2021 has brought to us. And actually, the not selling equipment in the first few months of this COVID in 2021 has been really helpful in some of the improvements that we've made. We, slow down selling equipment, gives us time to improve some of them.
Well, this has been a great conversation. I've learned a lot, and I thought I knew a lot about scrapers. So I thank you a lot for your time. Hopefully we'll be able to do this again. We'll be able to ask our viewers for maybe some conversations or some questions they have for you specifically. But this has been great. From B&B's perspective, we're just thrilled to be partnered with OEM, and we look forward to selling a lot of equipment. And hopefully this will be a long-lasting relationship.
Looking forward to it. Thanks, Kevin.
Thank you, Rex. This concludes episode 9 in a series of podcasts focusing on the basic principles of concrete surface preparation. Make sure to join us for episode 10, where we dive into the proper preparation techniques, materials, and best practices of residential garage floor coatings. For immediate access to hundreds of industry tutorials and product demonstration videos, we invite you to visit the By Manufacturers Direct YouTube channel. Simply visit the By Manufacturers Direct homepage and click Watch More Videos. New videos are added weekly, so don't forget to subscribe and click that bell icon to be notified when we post a new video.